Right. Everyone can still see the screen, right? So I'm just doing this weird thing where I don't see that green on light anymore as soon as I start recording.
Yeah, it's still there.
Okay, cool. All right, so welcome everyone to this, what did I call it? The Context, Scope, and Closures Lab. Not lab, Scope, Closures Study Group. In the study group, we're going to talk a bit about how code is being executed in JavaScript. I'm going to ask for a little bit of participation from people. I won't call out anyone by name, so if you want to participate, you can unmute yourselves. You could also type it into the chat if you want to do it that way. But essentially, I'm going to give a couple examples or walk through a little bit of how code is executed, and then I'm just going to ask the group to see if anyone then, once in the second example, wants to walk through it and how I just explained how they were executed and explain it now with this new line of code. So just like a little mirror, just to make sure that people are understanding how it's working. And we'll start off simple at first. We'll start talking about the variables. Then we're going to move on to functions, and then multiple functions, calling functions. And then eventually, I'm just going to leave this manage participants open so I can see everyone in here. And so then after that, we'll talk a bit about scope and closures within the context of everything else we've been doing. Well, let's get started. So to explain a little bit, we're using this little whiteboard app. Really what this whiteboard app is going to allow us to do is just going to allow me to put in some code real quick. It's not going to be able to run any of the code I put. It's just mostly going to be the text, and then we're going to draw arrows to show how things are being executed. So on the left-hand side here, we have our code, which is where I'm going to write the code that we want to execute. On the global variable environment, it's going to be our variable when our code is being executed. The variable environment is where all our variables are living. Sometimes we call that the execution context, where our information is being executed. One important thing to know is that JavaScript usually always just deals with variables. And that's why when we're running code line by line, it executes whatever's inside of there to return a value. JavaScript really only cares about values and where we're storing them. So that's what we're going to talk about. And if anyone has any questions, feel free to type it into the chat. Feel free to unmute yourself. If someone sees that there's a question in the chat that I did not enter or that I did not look and see, definitely unmute yourselves and please let me know. Okay, so let's start talking about our code. So we're going to start talking about variables. We're not going to talk too much or really at all about hoisting. We're going to really concern ourselves with let and const, since they're the ones that are going to be used most predominantly going forward in code. When you're writing code, we're not going to talk too much about var. But if anyone has any questions at the end, we can kind of explain how var is working. But for now, let's start with let and const. So let's make a little text tool. So let's say we have some code. We have let number1 equals 1. And we're not done here. Let number2 equals number1. Right. So we're going to have these two variables calling each other, or one variable calling the other. We have a variable number1. We're going to equal it to the number1. We're going to have a variable called num2, where we're just going to equal to the value of num1. And so that's the important thing to know. Is like we're assigning the values. We're not assigning the variable itself. We're assigning the value that's part of the variable number1 or num1. So in this case, if I were to come down here and say something like num1 plus equals 2, which is saying number1 should equal number1 plus 2. This is a shortcut way of saying that. So let's talk a bit about how our code is executing. So we'll say this piece of code is up here. So we're going to go line by line. So the first thing to know is that when we're inside of our global variable environment where our code is being executed from, first thing we're going to do is we're going to go through our code right now, and we're going to run it line by line and create the different labels that we need to keep track of in our variable environment. So in this case, the first thing we're going to do is we're going to create the num1. This is our label. And we're going to assign it the variable of 1, because that's what we have here on the left-hand side, num1 equals 1. And then we'll come down inside of here, and we're going to assign num2 num1, right? Since this is a label, we have to, again, we can't work with variables of passing variables around in JavaScript. JavaScript is only really going to care about the value. So we look to see what the value of num1 is. In this case, it's the number 1. So we just assigned the number 1 in there. So now our code is keeping track of num1 equals 1, num2 equals 1. And then we actually execute our code. Since this is a variable environment, we're not labeling our code anything inside of here. We're not writing it inside of here anyway. We just display whatever we want to execute. In this case, I'm not telling it to console log or do anything, so this would just go off in the background. So let's instead label this result equals number 1 plus plus or equals 2. So we'll get back a variable called result. So the next thing we would do in this line of code here is we would create the label of result. And we would execute the code in there. So let's write it in the longhand. So what we're really saying in that line of code is number 1 plus 2. I wrote 2 in there, yeah, plus 2. And we also have num1 equals, and let's move this a little more to the left here. Cool. So this is really what we're saying in this line of code happening over here. And can everyone see when I highlight this in green?
Yeah.
Okay, cool. Yeah, so this is what we're doing inside of here is this line of code. We're saying number 1 is equal to number 1 plus 2. So since we only care about the values, we can't really just store this information in here. We need to execute it to get back what's happening. So we'll go through here. And since this is an assignment, we're not really going to care about that for right now. We're going to just remove it. And we're going to actually execute the value we have, number 1 plus 1. The number or the value of number 1 is, if we look back up here, is 1. Right? Our code looked up from where the label of number 1 was and changed it out to its value. So 1 plus 2 is 3. So we finished executing our code. But again, we had the assignment of number 1 plus equals 2. So what we did is then we also went back to our value up here, the one we were keeping track of, and then changed this to 3. Since we said number 1 is equal to number 1 plus 2. So we changed the value back up there. And then this is what's going to be in our result. So this is what's happening at the end. This is our code has finished executed. These are the labels that were created. And now we get into this concept of, we won't go too deep into it, but the concept of garbage collection. I'm not keeping, past these 3 lines of code, I don't want to use this anymore. So all of these things have been marked for being deleted. So after a certain amount of time or after some other process that we won't, there's a whole algorithm behind it. If you looked at MDN, you can find out a little bit more about how it works. But these essentially get marked for deletion. So at the end, once we're executing another code, this will eventually get deleted and we'll continue on with our business.
I have a question.
Yeah,
about
go ahead, Mike.
Could you get those back? Can you undo the deleting? So when you went through and did the compilation compilation phase and execution phase, right?
Yeah, so this is so all of this here is the execution context, the execution phase.
Okay. All right, because, I was kind of confused at first because I thought you're doing both phases, so you're only doing execution.
So we're executing, like, and generally what's happening to go on to that point is generally there is let's say another thing here, and we'll call this the memory, right? So this is where we're keeping track of that information. So generally when we say we create a label here, we're creating a label inside of the memory that's referring to that.
Okay.
And this refers to 1, which is why when I then ran this line of code, this refers to the number 1 that was in the memory. This was just a way of kind of putting them a little bit together so we can see the whole execution of it running. But we can do the memory part too. Just generally, like the memory part will go into here. We will still have access to the labels inside of this because this is where we're keeping track of the actual variables themselves. But this would happen more in the background in the memory. And we'll see this come a little bit more into play when we start talking about closure.
I was under the impression that during the compilation phase, it read all the labels, and then during execution phase, that's when it actually assigns the values to the labeled variables.
Yeah, so it does that. So this is kind of like a shortcut kind of way of doing it, both of them. But yeah, so this is because we would execute this as the memory, and we would put this, if we rewrote the words here, we would say probably this is going to be the execution. But the variable environment kind of accounts for both of them, what it is the result of the variables being executed.
I just wanted to make sure I didn't misunderstand. Thank you.
Yeah, no problem. Thanks for the question. So yeah, so the variable environment in this case is going to be, we're kind of splitting up the memory, and then we would have something else here be the execution, and then the variable environment is the results of all of that happening. And again, once this has finished and we no longer, in this case, we haven't told it we need access to these, it would get removed from the memory, which means we no longer keep track of it. There are different ways that that's going to change. When we talked about closure, we'll see how that changes in a little bit. Cool. So let's go, why am I deleting that one? Let's go through different Come on. Cool. So that's a different example. Let's bring something else back here. So we'll do text. And let's do let string equals hello. String 2 equal my, and we'll do let result equals string plus string 2. Okay, so who wants to walk through what's happening here? And what is the first thing that happens when we're executing our code from the left inside of our variable environment?
We put the label into the global variable environment.
What is the label called?
String.
Yeah, so like Sushi said, variables are declared. So yeah, so we're saying string. And what is the value? So again, we're kind of like shortcutting both the memory and execution in this step. What is the value that we're assigning to this label of string?
Hello.
Yeah. Okay, what is the next thing that happens?
String 2 is the label assigned to another variable in the global variable environment, and that value is goodbye.
Yeah, so we assign a label of string 2 with a value of goodbye. Okay. And I will say this time, someone else, what happens next?
Then result would be hello, goodbye.
Yeah, and so one thing I would say is like, so if we, a little more detailed in the sentence, we can say we create a label of result and we assign it the value of string plus string 2, which in this case is hello plus goodbye, which would give us hello, goodbye. Just to be a little more detailed in what's happening in there. But yeah, we get the result of hello, goodbye. And then the same thing happens when we don't need this later on. It gets marked for deletion. And our code has finished executing. Cool. So now let's start talking about how all of this works in the context of functions. So let's write a function up here. Function add x. I'm going to write a function here. This is going to return x plus 2. And we will say result equals add 2. Okay. Who wants to tackle what's happening here? First thing that happens.
I think the first part, if we compare it to the examples you put before, the label in this case would be the result. So the result would be the label that you'll put in the global variable environment.
Yeah, so comparing it to the results we had before, like, yeah, so we would put we're going to result the label and then do the add 2. But remember, our first step above there is the function declaration of function add x, return x plus 2. So that is actually the first step we do. We create a label of add and we assign a function to it. Okay. And the function is going to take something in and then output something back out. So we have our add function. We haven't actually executed. We haven't stepped inside of the function at all yet. But we do have that function linked there in case we need to use it. And then we'll do, like you said, we would create the label of results. And now we want to execute the function. Now we're doing add 2. So now we get to kind of play around with what we have defined up here. And this is actually when we now create another execution context. Functions themselves have their own execution context or their own variable environment where they're keeping track of their information. So in this case, let's write this back up.
The value of add is the function definition. And
exactly.
Now that we're looking for the value of result, it's because you're actually executing it with the argument 2 is we're doing that local variable environment to find that.
Exactly, yeah. So our value for add is the function itself. We haven't run or executed anything, so we don't know about x plus 2 yet. We just know that this is the function that we can run. Result is when we're actually going to execute the function inside of add2 because of the line of code we wrote here. So what is the first thing that happens inside of our local variable? So taking a step inside of the function, we are now inside of here. So whatever within the curly brackets is a way of saying that. What is the first thing that happens?
I think Christian had it in the chat.
The first, Christian says the first thing is x plus 2. So that is actually the last thing that happens here.
Does it take in the variable?
Yeah, you're right. It takes in the variable, right? The parameter we have is add x. So we need to create that parameter inside of here for us to have access to. So we have x that came in from our function's definition. What are we assigning to x? What is the value of this label?
2.
Yeah, 2. It's the one we passed in. So we have 2 inside of here. Cool. And now we can do the x plus 2, like Christian was saying. Now we have, because now we need to execute it to get something back. We haven't really called this, but I'm just going to label it output. This is what's going to come back out from our function. So here's when we actually do the x plus 2. This is now us trying to get that final result of the return. And again, we look up, do we have access to x inside of here? Right, it's right defined right above us. So we switch this out to 2, which means 2 plus 2 is now 4. Once it's finished executing, we now have a value. We no longer have that operation or that, that operation that was happening inside of it, which means we can now return this since we have the return key up there, which makes our result at the end not be the function itself, but the value of 4, because the function has run. And this is now getting ready to be deleted.
So just to clarify, once it's inside the function, it exits the global environment, goes to a local environment, and then once it gets the result, it goes back to the global environment from the local.
Right, exactly. And so the thing I would say about it is it's because I told it to return that value. If I did not say return inside of here, this wouldn't come back out. It would just execute and vanish off.
Okay.
And then what I would get here would be on the value that it gives back by default, since I haven't told it anything, is undefined.
Okay. Thank you for clarifying that.
So this was 4. So we'll put 4 inside of here. And we'll just keep this little local variable environment so I don't have to recreate it next time. So yeah, so we have this inside of here. So let's get rid of this. Let's add on to our add2. So what I want to do now is, let's say we have let number or num equal, let's say 2. Actually, let's do 4. And I'm going to change this out to num. All right. So who wants to take this? What is the first thing that happens? Yeah, Paul.
You would identify the num, the variable num. You put that there, and that value is 4.
Yeah. Well, first thing we're doing is we're creating the label of num, and we'll assign that to the value of 4. Okay. What is the next thing that happens? Interesting. Yeah, stating the function. We create the label of add, and we assign it to. Yep, this Mike said in chat. We assign it to the function that we're creating, the function definition itself.
So I just have a quick question. So
Yeah.
add is a function, like we're not assigning a variable to add because it's a function. Because I know a variable and a function, but I think I'm getting confused if it's add a variable and not a function.
Yeah, so add is the label for how we can access this specific function. This function is the chunk of code we're going to run whenever this label gets called. So right now the function is really, so let's draw this. The function is going to be, I change the size of this. Yeah, so let's do this. F. Let's make that bigger. Right, so we have our function inside of here. So this is really what is add function, and it stands for what we want to do. In this case, we're doing x plus 2. So x plus 2. And this function is going to take something in, which is going to be our x, and then output something back out. So this here is what I mean when I say that we're assigning the function definition in here. We're assigning a function x plus 2. It's going to take something in, our value of x, and then output whatever the result of x plus 2 is. But we haven't actually run the code, so there's no value to assign there, like we're going to do with 4 or 6 and things like that. This value is just a direct reference to what the function we want to call is. That answer your question?
So Alice, is it safe to say, so like, just in terms of like what you have listed in our code, so can I, in the number form type of thing, we should think about it as 1 is let num equals 4, 2 would be function add x, 3 would be the constant result, and then 4 would be what's actually within the function, return x plus num. Right?
Do you mean, so do you mean like 4 like as in what it's executing, or 4 as in like what we're creating to represent that? Because this is really like the variable bind is what's representing these specific values we're trying to keep track of.
Yeah, but the last thing that gets executed, I mean.
Yeah, so the last thing that gets executed in this example here would be the value of whatever add2 is. So this whole chunk of line here is the last thing that gets executed. We create the label, and we quickly run it to get back the value. So it's a similar process to what we're doing up here for these. We're creating the label, assigning the value, creating the label, assigning the value, and we're going to do the same thing for result. The only difference is that this time we actually have a function we need to call to get back that value. But it's a similar process to what's happening to these two up here.
Okay.
So let's take that. And so like we were saying, so we now take and create this label. So we'll do result and we'll execute it. So we'll execute it again. We'll bring it back out here inside of our execution. What's the first thing that happens? Yep, x. We create the label of x, and we assign it the variable of 2, because that is what we're passing in. So we have the parameter of x and then the argument of 2. Okay, and what happens after we do that? And I'll just put this label here because this doesn't really exist in there. It's just how we're going to visually keep track of it.
Would it then be 2 plus 4?
Yeah, so we would take in the code that we want to run, x plus num, right? So this is the actual functions, the meat of it, what we want to have returned at the end of the day as the output. So we will run through the steps like we do. We do x. Do I have access to the value of x? Yes, it's right above me. It's within my local variable environment, so I can replace this as 2. And then we get to the point where we now have num. And is num within this local variable environment? No, yeah, exactly, no. So we now step out from this environment to our parent, to whatever we're inside of. In this case, result is the one that's being executed, right? So result is inside of our global variable environment. So my local variable environment of result here has access to whatever is inside of the parent of result. So in this case, I can look to wherever, so this is like looking up here, I can look inside of there and see that num is equal to 4 from up here. And I go ahead and I replace it. So now with 4. And let's get rid of this arrow.
Can you just repeat that last step? Because num wasn't a part of the local environment, and then you did something to make it like that.
Yeah, so let me get rid of these arrows. So we'll say we'll go back to here to having num, right? So we have num. So the first thing we have to do is see if it's within, do I have access to it within my local variable environment? And we can say like, we only have a label of x. We don't have a label of num. So I need to look outside of this local variable environment, which means result now needs to, because this again is all of this running here on the right-hand side. This is all what's happening as a part of result. This is all going to be added to this line of code here at the end of the day. So I need to look outside of myself, back to where result is actually being executed from, which is our global variable environment. And now inside of here, I can say, do I have something called num inside of here? I have add, and then I have num up here. So since I have access to it based on where result is being called from, I can go ahead and change the value that I had here in the output. I can change it from num to 4 because it's the value that I have access to outside of here. If I didn't have a num out here, I would get an error that the num doesn't exist. It doesn't know how to do 2 plus the value of num because num doesn't exist.
Kenton, did you get to the part about scope chaining yet?
Maybe. I don't know.
That's what this is about, because when we're in the local variable environment, we're in the function scope, like the function, the add function scope. And because it's part of the global variable environment, like the function is in global, it has access to variables defined in global.
Right. Okay. So I think I get. Yeah, I get that. I get that.
Yeah, the way you can think of it is a lot like thinking as being part of an onion. So we have like our inner core and then the outer cores. Our local environment starts off here in this inner core. And if I can't find something inside of here, I will look through my outer layers until I can find it. The outermost layer of this onion will always be the global variable. It's where everything is running from. It's our browser itself.
So it's like, so would the local environment be like the child and the global would be the parent, something like that?
So you can think of it in that context as well. Okay. And in this case, we only have 2 layers to our onion. Can I not select that? Yeah. So in this case, we only have 2 layers to our onion, our local environment, and then immediately our global one. Cool. And so we then output this 2 plus 4 equals to 6, which then comes back out here, and our result is now 6. We've executed this. Cool. So we've gone through this one. Let's go through a little beefier one example. So what we're going to do is we'll take these out. We are going to create something new here. All right, so we are going to create multiple functions this time and get a result that we're going to execute. So let's say we do function, we'll do multiply. I spelled that right. No, multiply by 2. We're going to say this is x. We're going to go inside of here, say this is return x times 2. Let me just add these semicolons, even though this is not actually going to run. Throw another x inside of here, and we'll do return x plus 3. Another one, divide by 3. And we'll do x divided by 3. Okay. Yeah, we'll do by 3. We'll call this one by 3, so we follow the name. I'm just checking something real quick. Okay. So let's actually, yeah, let's do that. And so we'll come back down here and we're going to say const first result is going to be equal to multiply by 2. We'll pass it 11. We're going to say const second result is equal to add 3. Initial result const final result is equal to divide by 5. Yeah, and then we'll pass into this one second result. Okay, let's talk about this code here.
Alice, that second parameter, yeah.
My old name for it. First result, second result. Okay. So this is our new code. We have a function multiply by 2 that takes in an x, that's x plus 2. Function called add by 3 that takes in an x plus 3. Function divide by 3 is return x divided by 3. And then the constants of first result, multiply 2 by 11. because the second result, you go add 3, or add by 3. That's what that should say, which is going to take in our first result into that one, and our final result, which is going to divide by 5 based on whatever we got back from our second result. So let's run through this. What is the first thing that happens?
In this case, wouldn't it be the function since there's no, I guess, starting variable? If that makes any sense.
And what do you mean by the function? Which function?
So if we're going but in order, would it be the multiply by 2?
Yeah, so we create the label of multiply by 2.
I gotta start using that terminology, creating the label, multiply by 2.
Yeah, yeah. Let's create the label of multiply by 2. What is the value of multiply by 2?
X times 2.
So remember, in this case, we haven't run the code, so we don't know about x times 2.
So function, right?
Yeah, the function. So this is our function. The function here contains x times 2, but we haven't actually run it, so we don't have a result based off of that. We have just the function itself. Okay, and then Paul in the chat coming in with the rest of them. Yeah, so we're going to create the label for add by 3. Add by 3, assign it to a function. So this is the same things happening to these line of code. Divide by 3, or divide by 5. I put, yeah, put divide by 5. Why did I put 3 there? 5. A 5 by 5. Create a label of that. We assign it the variable, or we assign it a function, a value of a function. All right. What is the next thing that happens after we've done these functions? And we've assigned the labels to them.
We declare a variable with the label first result, and then assign it the value of multiply by 2 with the argument 11. So
Yeah,
return the value of that.
Yeah, and to be as like descriptive as possible, we'll say like the first thing we do is we run the function and on the label of multiply by 2, which means we have to create a new what? When we run the function.
Local variable environment.
Yeah, we create a new execution context or local or variable environment. So we go from here to up here. Cool. What is the first thing that happens inside of here?
We declare the argument that's passed in. So the label X is the variable and 11 is the value.
Yeah. Yeah, so we declared the label of X. That was our parameter of our X. And then our argument was the value of 11 that we assigned to it. So we move on from here. We'll say we have our output because we're going to return something. And now we run the actual return line inside of here, X times 2. We look upwards because we know we have access to X within our local variable environment. So we replace this with 11. And this now turns to 11 times 22. Or times 2 is 22. Like that.
Spoiler alert.
So yeah, spoiler alert, 11 times 2 is 22. And now we return this. So now we go back from our output here, back outside of here. And we will assign this to 22. And what this means now is that I no longer need this local variable environment. So I mark it for deletion. And now we go on to our next line. We have our second result label. What do we do? Oh, go ahead. You have a question?
I have a question about. Never mind. It's kind of it's a little bit off topic, so never mind.
Yeah, we can come back to it at the end. Okay, so we have our second result label here. What do we do now? What's the next thing we do after creating this label?
So going back to the whole local variable environment, would we then see that, okay, the value and, well, we have to first state the variable, which is first result, right? But then in
Right.
this,
So the thing to keep in mind here in this case is that we are not, so one thing I would say with the language wise is we're not going back to the local environment. We're creating a new local environment for this function
Yeah.
now, because now we're running at by 3. So we go inside of here. And what did you say the label is that we're going to call inside of here?
so it's pointing to first result right there, but it still will be X because that's what's listed in the function.
Yeah, exactly. X is our parameter, the label we're going to use within this function to refer to the argument we pass in, which is first result, or the value of first result.
And then so the value would then be what was listed as first results, which is 22.
Exactly, we have 22. And then we're going to run our output here, which is output, which is equal to x plus 3. We run this again. This is now 22, since we know that that has a value. What is 22 plus 3?
5.
Yeah, 25. And that is our output. So we now go back. And the value of this is now 25. Cool. And we no longer need this, so we'll just mark that for deletion. Boom. And we go to our next line, which is creating the label of final result. And we run through similar steps. We now go ahead, create the X value, assign it to the value of second result, which is 25. We do the output, return X divided by 5, which is 25 divided by 5, which means once we've run through our execution contents here on the right, we end up with the value of 5 as our final result. So those steps all happen. I just shortcut them a little bit in the interest of time. Yeah, so we came back. This is how we executed our code. We have access to this information. We got 22, then 25, and then 5. We did everything kind of in the order that's inside of here. Are there any questions so far about, executing this, anything like that? Okay. If there's no questions, we are going to move on to talking about closure and how closure applies to what's been happening inside of here. So let's get rid of this. We no longer need access to this. So, okay, we're going to write new code inside of here. Let's give myself a little more space. So we're going to write a function. It's going to be a counter. It is going to do this. It is going to do let counter equals 0. Function increased num by, we'll be verbose in this. It's a little easier. And I would do return count. And we're going to do return increase. Okay, let's do const new counter equals counter. Const result 1 equals new counter 2. Increase. Oh no, I can do this. Okay, cool. Who wants to take us through the first thing happening here in our global variable environment?
The first thing would be to identify the functions. So you have a function of counter and a function of increased. So the label for function 1 would be counter, and a label for function 2 would be increase.
Yeah, so remember right now, function increase is inside of the counter. In our global variable environment, we haven't run this function to see what's inside of it yet. All we've done is run what's in the outer sections, this counter and these new counters in result 1 down here. So because of that, we actually don't create the label for increase. We don't have access to it outside of this counter function. So what I do is I create the label of counter and I assign it to a function. Then the next thing that happens is I move down to the constants because I have not yet gone through here at all. That's the function that's waiting to be executed inside of here. So I'm moving on from that function. I don't run it until I actually need to run it. So I don't know what's happening inside of there yet. And now I create the label of new counter. And what is the value of new counter? Or how do we get the value of new counter, which is counter with the parentheses?
You create a new execution context.
Yeah, we create another new execution context. Because remember, we're referencing counter is up here. So we're now running the function itself. So we create a new execution context. This is now the execution context for counter. Like this. This is our execution context for counter. Yep. Local, yeah, let's do local counter environment like this. This is the execution context for our counter up here. So what is the first thing that happens inside of the variable environment for counter? Oh, yeah, Paul said, Paul said we create the label of counter and we assign it the value of 0.
It's count.
Oh, I did say count. We create the value label of count and we assign it to the variable or to the value of 0, because that is what's happening in that line of code. Okay, what is the next thing that happens?
Now, what Kenton said with the increase.
Yeah, exactly what Kenton said. Now we have access to this function. Now we can create the label of increase and assign that this time again to another function. Because this time we haven't executed the increase code yet. And our output here, and I don't even have to write label because we have a label. Our output is return increase, which means this is actually the value of new counter. It is the function in here of increase. So it has now become a function. So our value or our function inside of here called increase is what is the return value from this local environment. It's what I've chosen to return down here. So new counter is now really the function of increase by a different name. So everything that's happening inside of here is the value of this, which is then returned to be the value of new counter.
That makes so much sense now, like seeing it, because like even though that count variable is outside of increase function, it's still included in that new counter value.
Yeah.
So it has that memory value that increase doesn't have as a function. So that's like where the closure comes in.
And so then going on to that concept of closure, I have the increase in here. So what I'm actually doing is, in this case, since I have a function within a function, at the moment that I have this increase function in here, what increase function has done is also created a link to a different type. So in this case, we'll call it the memory. So this has a different type, which is like it's memory inside of here. And this is really its, why is that so tiny? I'll just fix this in a second. So it's got its memory inside of here. Let's increase this to size. Yeah, cool. So it's got its memory inside it. So it's actually also at the same time that it created the function or created the label of increase and assigned it to the value of function. At the same time, I don't think I changed the color there. It created a link to its memory. It has now created not only the function, but a link to the memory of when it was created. In this case, its memory is its variable environment. So I have told it to kind of almost, and there's a couple different names for this. Will Sentence, which a lot of this talk is based off, he calls it the backpack.
Yeah.
So this is the backpack that we're going to refer to. This is what's getting attached to this function and carried alongside of it. So inside of the backpack, we have access to whatever this function needs to keep access to in order to function correctly. So in this case, the only thing we need access to is a count, which is assigned to 0. So it's keeping track of that inside of it. Once this local environment, once we've moved on from new count to go to result1, we no longer have the local environment, but we do still have the link to the spot in the memory that referenced the count of 0. So this gets, so we can say this gets, nope, not deleted that way. This gets deleted. This gets deleted. There we go. This gets deleted. But we still kind of have, let's do this, a link to the memory. Whenever I need to access it, I still know that count equals 0. And the important thing is to say, like, we have access to what the function needs to run. If I had another variable, like let random equals a bunch of gibberish, I wouldn't keep access to that because my function increase doesn't need to know about that in order to function properly. That gets deleted in the background, same as our code from the previous examples was getting deleted. It's only keeping track in its backpack what it needs to in order to function correctly. In this case, the count, because we're accessing the count from inside of there. Does that make sense? Does anyone want me to explain it out again?
Yeah, that.
There's a couple different names for this. One name is, this is what we consider, or this environment up here. No, that's not what I wanted to do. This up here, this local environment in this memory store here, we call that the local scope or the lexical scope. This is the lexical scope of the function, where the function was created from. And it keeps the information that it needs to have access to run properly. That's its lexical scope, which is when we say something looks the information up by its lexical scope, we mean that it's looking it up through the link it has to when it was, to the variables it needed to when it was created. That's how the arrow function knows it's this value versus using the one from where it's being executed currently. It remembers the one from where it was created because it has that value stored in its lexical scope, this little backpack here. There's other names for this. This is called the backpack. Well, sentence calls it the backpack. Its official name is the persistent lexical scope reference data, which is a big word, which is why I like his name of backpack better. It's also called the closed over variable environment, or CLOVE. Again, backpack kind of combines a little better what's happening. We're carrying this information kind of in a backpack along with this function. So whenever it needs that information, it'll look through its little backpack, find the information it needs, and use it. Well, so now that we have that link, we're going to move on. And let's move on to here. So now we get to result1. And now we get to execute the value of new counter 2. So the value of new counter, again, is the function that was formerly called increase. So what that means is that when we now create this local environment to run our code through here, what we have in here is the first off is we will create the label of num. The label of num is the value we just passed in, the argument 2. And now, let me get rid of some of these arrows. Oops, that's so it doesn't get confusing. And that's so weird. Move. Boop. There we go. And so let's, no, that's not the arrow I wanted to delete. Delete that one. This is still linked out here. Okay. So we have our num2. And now when we get to the rest of our code, we have count equals count plus 2. So now we need to create the rest of our code. We need to say count plus num. We don't have a count here. We don't have something to find the variable up here. But again, we have that link to our backpack. So it's able to look through its lexical scope back to the function, or in other ways, this would be a more direct connection to its backpack directly, and see that the count is defined there. So this is the equivalent of it having that access to it up here, of it being defined when the function has been created, but it's technically stored in a different place through its lexical scope or in its memory. So it has access to this from its previous birth when it was created. So I can say there's my count. That's why I don't need to write count equals or create a new label called count. It's the one down here. So I know then when I go to execute this code, this is going to be, and I should call this output, a little easier to see. So we'll call this output, and we know our count here is going to be 0 because that's inside of our backpack, inside of our memory. num, it lives within this one because we know that got created when we executed it. So we'll change this to 2. And then 0 plus 2 is 2.
Alice, I
And
have a question.
yeah.
How does the
Hmm?
so new counter, you're passing the argument in there, right? But how does it transfer from there to through counter and then to increase num? Like, what's the kind of path?
Okay. So one thing to keep in mind, let's get rid of these arrows. Nope, how did I do that? Yeah, get rid of this arrow here. Because remember, result of 1, well, we know right now that the result of new counter is going to be the function that got returned here, because we have the return statement. So this function no longer lives within an inner function called counter. It is being returned from it. So new counter is actually the function that was originally called increase.
Right.
So it's the function definition that was inside of there. I've assigned that to new counter. So then when I go to run this line of code, which is const result once equals new counter 2, well, anytime I've referenced new counter now, it is that function that we originally called increase, but now lives outside of the counter. It's that function definition. So now we're running this function in here. When we say new count, anytime we say new counter, we're running this function. So from here, we get the argument, or the parameter is going to be num, because that's what the label is for anything that it takes inside of itself. So we call it num up here. The value we passed in was 2. That's its argument. So we passed in the argument of 2, assigned that to num. And then output here, I just wrote to be handy. But we needed to have access to a variable called count. And we know that count is not being defined in here. I don't have a var, a let, or a const. I'm not defining it. So that kind of signals to the function that this variable has already been defined. I need to find it. So it, again, takes its step from its inner core onion to its outer onion. In this case, the outer layer of it is the link that it had to when it was created, its memory or its lexical scope. And inside of that memory, because this is where we go to first, inside of the memory is the count of 0. So there's where our variable definition exists. And that's why I can then take count plus num and change that from count to 0. And then num was the value we passed in, the label we have inside of here, so I can change that to 2. So whenever we're dealing with closure, the process of the onion, the core is the local environment we create every time we execute the function. The outer layer past that is it's the context from which it was originally created in. And then past that would be the layer that it's our global variable. A global variable is always the endpoint no matter what. But in this case, we kind of attached a layer around this specific core of the onion that is always going to be where we have the variables that it needs to have access to when it was first created. Does that answer your question?
I think so. I think I'm gonna have to watch the replay of this to really get my head around it.
Yeah, and it's kind of like what Paul was saying. So yeah, think of it as new counter is really, so we're really taking, so when I'm saying down here, new counter 2, what I'm saying is really increase 2. Because that's the name of the function inside of here. We just changed it to a different label.
I have a question. Like, I don't know if you just picked this as an example to show closure, but just the logic of the counter function, having that let count equals 0 in the beginning, like it seems like if you want to count anything and then it just resetting every time, like is
Resetting every time. What do you mean by that?
if you have let count equals 0, am I missing something? Like,
So one thing is, like, remember, new counter here is just this function inside of here. We are never, unless I call counter again, I am never running the lines of code in this one again. I'm only running whatever's inside of function increase.
okay.
So in this case, so I have count 0 here, And our output is 2, but I also had count equals up here, which means I need to edit my lexicoscope. I need to edit my memory because I'm telling it I now need to keep track of this variable. I need to update that from 0 to 2. And that's when I return this value. So this value out here, our output, gets put inside of result 1.
Okay. That's
And
why I was confused. We didn't finish. So that gets put as result 1, and counter would return the same, would return 2 as well.
Right, and then in this instance, if I do const result 2 equals new counter 4, we go through the similar steps. I have the num. Let's add that back in here. Result 2. The label of result 2. I run the function. So again, I'm running new counter, which was formerly increased. I create the num2. I need to do the count plus 2. Again, I don't have access to count when I ran it again, but it's inside of my memory. I look inside of my memory, and now the number says 2. It doesn't say 0 anymore because it knows that I changed it originally. Because it's always keeping track of this in its backpack. It's always updating it whenever I manipulate it and save it in this way of count equals count plus 2.
Gotcha.
So now it changes this to 2. And then 2 plus 2 is 4. So that's what gets returned from here.
Okay.
Is num supposed to be 4 because you put new counter 4?
Oh, yeah, that's a good point. Thank you. Yeah, so then this would actually be 6. And this would be 6. And again, I had the count equals count, so this gets changed into 6. The only time that I am going to do this part again in function is if I created a new counter. So if I went count like this, then this result is not going to be, this result is going to run just like new counter did and create another function called formerly increase. And this one has its own backpack. They can't share backpacks. They have its own backpack where its count is going to be 0. But this one is, so you can think of these two functions would be completely different. They both were formerly called increase, but they were created at different points, so they can't share the same backpack. They each carry their own information. Just like two people can't exchange memories or experiences. In that way, yeah. Let's see, any questions in the chat?
Question.
Yes, Paul.
So the way you have it like that right now, it would still do the same action, just different, just different memory part. Like the same function, it'll still do the same count plus number, everything else, but it will keep the memory separate. That's what you meant by that, right?
Yeah, so I can call this counter, yeah, if I call this counter 2, which then means I would do counter 2, I would then go through the steps again. This is no longer
right. I get it. I was just wanting to make sure that it was in the same. It's the same function that you're doing, but there is the memory and everything else is a little bit different because, like you said, it has a different ID and everything else.
Yeah, exactly.
Okay.
Yep, I'm just doing it here so everyone can see
Got
it.
it.
Yeah, then this would be increase function. And then, so we still have this one here. This is going to be the memory for, this is new counter memory. Oh, and then we create another one. This is going to be counter 2 memory. And inside of here is going to be whatever information it needs to run again. So here's going to be our new count of 0. And so let's make this completely different. These will be different colored lines. What color? That one. So it'll be this one, and then this is its memory. So now it has to link to this memory because it's counter 2. It can't access the one from new counter. They're two different memories, two different scopes. Hey, Gregory said, so a closure is a function that's returned by a function which has access to variables defined outside of it. Yeah, so it has access to the variables defined within its outer function at the moment that increase was created. You can't add any new variables to counter and expect to have new counter have that information. It only has access to the variables it had when it was created, that were around it when it was created. This way we kind of give it like a persistent memory that we can now keep track of, which is really cool if you want to get into functional programming. They make heavy use of that. Cool. Okay, yeah, if anyone has any questions, always feel free to reach out. We're a bit over time, so we'll end it here for today. Yeah, thank you everyone for stopping by. I will edit the recording of this and I will upload it to the video lecture app. Yeah, thank you everyone for coming.
Thanks, Alice. This was awesome. It really helps.
Thank you.
Have a good
You
weekend.
cut out for me. Sorry, I didn't hear what you were saying, Meg.